我来读书了。好的，我读这个 How things work. How things work. What's the sound? You notice me translate my words to Chinese cause my daddy told me to translate some words to Chinese, just the starting words to Chinese. How things work. We're gonna read on page 126. Don't look down. How do skyscrapers rise to dizzying height? The inside scoop. The Burj Khalifa building in the United Arab Emirates soars half a mile, 0.8 kilometers up onto the clouds. A world record is held since 2010. But the new Jeddah Tower in Saudi Arabia would shoot past it, probably to be dropped after by a mile. 1.6 kilometers high super skyscraper planned for construction in Japan. World records fall every time you blink now. Compare that to 1931, which the Empire State Building opened in New York City. It was the world's tallest building for 4 decades. Chicago's super tall Willis Tower, formerly Sears Tower, held the title for 25 years after it opened on 1974. Want to know how buildings rise to record-breaking heights? Get ready to learn the secrets of super high skyscrapers. How could buildings get so tall? Why don't they blow over in the wind? How do they support all that weight? How's the weather down here? Just the facts. Defying gravity. Climbing high onto the sky is not a simple feat. The higher a building goes, the more weight it has and the more it feels the downward tug of gravity, the force that holds us to the earth. Without a strong foundation, the building would collapse right onto the ground. But that's not the only problem gravity presents to skyscrapers. Because they're so tall, buildings have a high center of gravity. The building is straight and nothing pushes it to the side. Its center of gravity should be smack dab over its foundation. But if somebody, like a really strong wind, pushes the top of the building, shifting its center of gravity to the side, that's a problem. Gravity pulls on it, creating a turning force that tries to tip the whole building over. To deal with those problems, skyscrapers have strong foundations extending deep onto the ground so they could resist the downward and tipping forces. The foundation push back, keeping the building standing tall. Building blocks. A skyscraper's foundation isn't the only part keeping the building upright, of course. Each skyscraper is unique, but they generally have inner skeletons of vertical steel columns and horizontal grider beams working together to support the building and handle forces of gravity. All parts channel that force of gravity downward. The horizontal griders transfer the force sideways to the walls and vertical columns which support the skyscraper's weight. Unlike buildings of old, a modern skyscraper's outside covering, its certain wall, does not support the building's weight. Tell me more. Push and pull. Buildings must handle multiple forces. Weight is placed on a vertical column. It's squeezed or compressed between the weight and the ground below it. When a horizontal beam is weighed down of the middle, it experiences two forces. It sags under the weight. The top of the beam is compressed while the bottom is stretched or subjected to tension. If the beam isn't strong enough to bear the load, the portion under tension will snap. For the tallest skyscrapers, wind is a more difficult challenge than the building's weight. Winds blowing on the top skyscrapers creates twisting forces or torsion. Very slender buildings also could experience wind vortices, whirlwinds that could pull the buildings side to side. Even the wind effects only produce a gentle swaying that could be enough to make people inside very uncomfortable. New from old. How could recycled materials become innovative buildings. The inside scoop. Have you ever heard the saying that one person's trash is another's treasure? It comes to buildings used and discarded materials could be gold. Not only they cut building costs, but they do Earth a big favor too. And do not think that using recycled stuff will make a building look shabby. Architects and home builders are using these materials on innovative and eye-catching designs. Step inside for a look at building with recycled materials. Sorry. Do these paper have 9 lives too? Just like that. The 3 R's. To go green, follow the 3 R's. Reduce, reuse, and recycle. Many form builders had that mantra to heart when they build, to hurt when they build more, Take that mantra to hurt when they build or remodel homes. They try to use as many recycled products as possible, and there are lots of options. Recycled plastic bottles can be turned into many products, including raw materials, fencing, and even carpet. Recycled steel could be a frame of house, and recycled windshields could be used for floor tile. Some builders even use straw bales and old tires from the structure of logs, which they coat in earthen materials. But not all recycled materials are hidden. Reclaimed barnwood was valued for its beauty. Glass bottles have turned onto walls and windows and even entire buildings into works of art. Reduce. That natural home is about reducing waste and a building's impact on the environment. Could you guess what it's made of? I think it's wood. Cause look, it's a brown. The house is brown. I always reuse. This bright modern house was designed to capture the beautiful views of Costa Rica. Could you guess what it's made of? I think it's made of box metal. Like box metal. I think it's called box metal. Recycle. This awesome green and brown Buddhist temple in Thailand is made of a common material found throughout the world. Could you guess what it is? Made of like bricks and leaves, I think. Look, bricks, the color of bricks, and leaves, the color of leaves. Tell me more. Adding up. A building is energy before it's even built. Making and delivering building materials use resources and energy. Wood comes from trees that are chopped down and cut onto planks. Stone is blasted from mountainsides, cut onto slabs, and also polished. Iron ore is mined from the ground and processed in a black furnace to make steel. Then all the materials are sent all the way to the building site on ships, freight trains, and trucks. The energy used to do all that adds up. It's called a building's embodied energy. People used to think that a building's embodied energy was pretty small compared to the energy of using the finished building. But now they realize embodied energy could equal the energy cost of operating a building for many years. Okay guys, don't forget to subscribe, comment, and like